Okay, so this last portion of Unit 5, we're talking about linear equations, and we're doing pretty much a segue to applications with linear equations. So in general, what we've done from Unit 4 to Unit 5 is we've looked at the slope intercept form of all linear equations, the slope intercept form, and it's just y equals mx plus b. Algebraically, we should be able to identify the slope of a line and the y-intercept of a linear equation. The only thing about this is typically we don't really stress is what we don't stress is the standard form of the linear equation, which is a times x plus by equals c. Now, the theme, how these are in common, is that if we wanted to transition from the standard form, we would have to move the x term and then divide that b by each term. And what we'd end up with is another form of that slope intercept form, which is negative a divided by b times x plus c divided by that big B. So what happens is this becomes our slope and this becomes our y-intercept. Okay? Other things we should be mindful of as we proceed towards this review. The slope has about two forms. So it could be y2 minus y1 divided by x2 minus x1. It could also just simply be the rise divided by the run. Other things we want to be mindful of. We want to be mindful of the equations and the slopes of horizontal lines, as well as vertical lines. Now, the equations of horizontal lines is y equals some number. The slope is always 0, and it looks like this. It's a horizontal line going over the y-axis. On the other hand, vertical lines have an equation of x equals a number. It's a vertical line. The slope itself of these lines are always undefined. What else did we go over in Unit 5? We went over x-intercepts and y-intercepts. For x-intercepts, y equals 0. For y-intercepts, x equals 0. And we solve for those values. Okay? Parallel and horizontal and perpendicular lines. For parallel lines, the slopes are the same. Slopes are the same. They're equal. For perpendicular lines, slopes are opposite reciprocals. And if you don't remember what the opposite reciprocals are, remember if you have 2, the opposite reciprocal will be negative, and it will be 1 over 2. If you have 3 over 2, negative 3 over 2, the opposite reciprocal will be positive, and it will be 2 over 3. So we see the transition. And be mindful of, for 0, the opposite reciprocal is undefined. On the other hand, for the undefined, the opposite reciprocal is 0. So I'm going to leave it at that and just move on to the actual review. Okay, so we're at Unit 5 review. Okay, the first question says graph the line using the table of values. So what I'm going to do is identify the slope and the y-intercept of the line and graph it. My slope, remember I always tell you if there's no number in front of x, we put a 1 there. So we have negative 1x plus 1. Our slope is negative 1. We divide by 1 to create that pattern, and the y-intercept is 1. So we start at 1, and then we go down 1, right 1. So down 1, right 1, make a point. Down 1, right 1, make a point. Down 1, right 1, make a point. Right? If I want it to go the other way, I go back to that y-intercept and I go the opposite direction. Up 1, left 1. So up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1 to create the vertical line. Now, if I want to gather points here, I don't even need my graphing calculator at this point. I can just go say I have a point at 1, 0. I have a point at 2, negative 1, 3, negative 2, and 4, negative 3. So I could gather any of the points on that line. For number 2, this is write an equation of the line that contains 2, 5. So I'm going to rewrite these points, 2, 5, and the origin, 0, 0. So the way I do this, I need my slope. They didn't give me a slope, so I say y2 minus y1 divided by x2 minus x of 1. I need some points here, so I'm going to put x1, y1, and x2, y2. And I need my y-intercept, which is b equals y minus m times x. And I'm going to go back and fill this in, right? So let's label our coordinates. x1, y1, this is my first set. x2, y2, this is my second set. This equals 0 minus 5 divided by 0 minus 2, or 5 over 2. That's my slope, right? Now, my points, I'm just going to write them out. We have 2 and 5, and then we have 0 and 0. The origin is 0 and 0. For B, I have 5 minus 5 over 2 times 2. Or I just simply have this equals 0. My final equation is, using B and the y-intercept, is y equals 5 divided by 2 times x, and my y-intercept plus 0. If I wanted to simplify that, I would just have y equals 5 divided by 2 times x, and here is the final equation. All right, moving on to number 3. 3 and 4. My slope is 2. I want to create a fraction, so it's 2 divided by 1. My y-intercept is negative 5. So I start at negative 5, and I use the slope for the pattern, up 2, right 1, up 2, right 1, make a point. Sorry, made a mistake there. Up 2, right 1, make a point. 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 And up 2, right 1, make a point. And I create my line, and I'm done. Simple as that, guys. For number 4, I have a slope of negative 2 divided by 5. I don't need to create a fraction because it's already there. And then my y-intercept is 2, so I start at 2. And then I go down 2, right 5. So down 2, right 5. If I wanted to go the opposite way, I would go up 2 and left 5. Create my line, and I'm done. For numbers 5 and 6, I need the x-intercept and the y-intercept. So for here, my x-intercept, y equals 0. So I have 4x minus 2y equals negative 8. So 4x minus 2 times 0 equals negative 8. And remember, I want you to recall what I told you. When you have a 0 times a number, it goes away. You just scratch it out. You're left with 4x equals negative 8. Divide both sides by 4. And x equals negative 2. That means my x-intercept is negative 2, comma, 0. I'm going to go mark it. Negative 2, comma, 0. This is my x-intercept. I'm going to make a little note. X-intercept. Now, for the y-intercept, I'm going to erase this, guys. For the y-intercept, this is where x equals 0. I don't want you to erase yours. I'm just erasing it so I can work. So where x equals 0, that means this x term is going to go away, and I'm left with the y term and the number term. So what does that look like? So 4 times 0 minus 2y equals negative 8. This goes away, left with negative 2y equals negative 8. Divide both sides by negative 2. And y equals 4. So here I have 4, 0 for my y-intercept. I'm sorry, not 4, 0. Remember, we were talking about y, the y value. So 0, 0, 4. So down here, or up here actually, is my y-intercept. This is my y-intercept. Okay, that's where it crosses the y-axis. And then I just create my line going through these points. And here's my equation. Here's my line. Okay. For the next one, we have the space. So remember, for the x-intercept, y equals 0. So that's 2x plus 0 equals 4. This goes away. I have 2x equals 4. Divide both sides by 2. And x equals 2. Right? My x-intercept is 2, 0. So right here, there's my x-intercept. For the y-intercept, I have x equaling 0, right? And so that means 2 times 0 plus y equals 4. This goes away, and y equals 4. Y-intercept is 0, 4. So go up here, create my point, and then I create my line going through the 2 points. And this is my y-intercept that I'm labeling. Okay, moving on. Graphing y equals 2. Y equals 2. I'm going to find where y equals 2. Find y equals 2 on the y-axis and create right here. And I create my horizontal line. Remember, the slopes of these lines is always m equals 0. Slopes of horizontal lines is always m equals 0. For the undefined, for x equals negative 1, my slope is undefined. And I create a vertical line where x equals negative 1. Here, x equals negative 1. Create my vertical line going up and down. And I'm done. Okay, now the function is shown in this coordinate plane. Plot 2 points on this grid to create the graph of the line that represents f of x minus 4. Well, this is f of x, right? I want to create f of x minus 4, so I'm going to plot 2 grid points on f of x. And the shift, the transformation here is I'm sliding down. I'm sliding down 4 because it's negative. So my new points, I'm going to do them in red. I have a new point here at 4, at 0, negative 4, and then I have a new point here at 4, 0. My new line, the shift going downwards, is f of x minus 4. Okay? Now, slopes of parallel lines. Now, we have to make sure it's in standard form. The y is by itself. Now, the slope of y equals 3x minus 2. These slopes are the same. Parallel lines have slopes that are the same. So the slope of this line, it's in standard form, y is by itself, is 3. The slope of a line parallel is 3. Now for B, the y term is not by itself. I have 5x plus 2y's equals 4. In order to get this y term by itself, that's right here, I need to move that x term. So subtract 5x's on both sides. 4 and 5x are not like terms. 2y's comes down, equals 4 minus 5x's. Divide both sides by 2. And y equals 2 minus 5 over 2 times x. My slope is negative 5 over 2. So my new slope of a parallel line is negative 5 over 2. Okay? Now it says write the equation of a line in slope-intercept form given the slope is negative 1/4. The y-intercept is negative 7. So I have y equals negative 1/4 times x minus 7. And that's it. It says write the equation of the line in slope-intercept form that passes through the points. 4, negative 1 has a slope of 3. This is where I have m, x, y, b equals y minus mx, right? So my slope is 3. The points I have are 4 and negative 1. I don't have b yet. I need to solve for it. So I plug these numbers in. I get negative 1 minus 3. Notice I'm using parentheses times 4 equals negative 13. My equation is y equals 3x minus 13. Moving on. 13. If the line graph below was shifted up 3 units, what would be the equation of the new line? So this line, we're going to call it, I'm going to call it f of x. If I shift it up 3 units, it's going to be 1, 2, 3, right here. At 3 units, I moved up 3 units. My new y-intercept is plus 5. The only thing I need is the slope of this line. I need the slope of this line. So we could do one of two things. We could simply say that it's f of x plus 5, or we could get the slope of this new line. I'm sorry, not f of x plus 5. It's f of x plus 3. I prefer if you got the slope of this new line by taking the slope of the last line. So I'm going to do the slope in red. So I'll pick 2 good points. One's at 0, 2. The other one is at this number here. I create my triangle, my right triangle, and I'm going down 1, minus 1, over 1, 2, 3. My new equation is y equals negative 1 over 3x plus 5. 14, we're talking about direct variation. Recall that I said all direct variations go through 0, 0. So it says the graph of an equation representing a direct variation passes through a point A. Plot 2 points other than A that are also elements of this direct variation. So once you have A and 0, 0, you can create the line. You can create the line. And then you can find the other points, right? So another good point on this line is right here. And I'm done. Oscar babysits his neighbors and is paid $8 per hour. So he's paid $8 per hour. Right? The graph shown describes his salary. So his salary equals T or K times T. K here, the rate he's paid is 8. So 8T, right? This graph expresses 8 times T, or 8 times the number of hours he works. Write an equation that represents the situation. His salary equals 8 times the number of hours he works. And we're done. Which could be an equation for the line shown on the grid. Here I have y equals 2. This is a horizontal line, so y equals -2. Y equals -2, sorry. Horizontal line. Okay. It says solve the equation. This is throwback from unit 2. So we're going to first look at our equation here, draw our railroad track, right? Distribute this negative to each term. So I have -5, the sign changes. And then I have negative times a negative, positive 2x's. And then everything else simply comes down. 4x comes down, equals comes down, 13 comes down. And then I combine, I add or subtract my like terms. Here, my like terms are 4x and 2x's, so 6x's in all, minus 5 equals 13. Add 5 on both sides, and I get 6x equals 18. Divide both sides by 6, and x equals 3. This is a one solution type of problem. 18, evaluate 9a plus b divided by b plus c. If a equals 2, b equals 6, and c equals -3. So I'm going to plug in these numbers. 9 times 2 plus 6. Notice I'm using parentheses. I expect you to do the same. And then on the bottom, 6 plus -3. Okay? I get 18 plus 6 over 3, or in general, I get the number 8. Here's my final answer. Translate 2 less than 8 times a number. This is -2 plus 8 times x, so 8x minus 2, or -2 plus 8x. Either one works. Which property is represented here? This is commutative. You flip it over, it's commutative property of multiplication. Circle each direct variation. There will be more than one, so direct variations can look like any of the following. Y equals a number times x, or k equals y divided by x, right? Things that direct variations are not. Direct variations are not, do not have a b term, so you would never have 2x plus 5. You never have an x term and a y term plus a number. Things like that. You only have the y term and a number times x, or y divided by x equals k. Also, direct variations are straight lines. They are never curves. And the straight lines have to go through 0, 0, or the origin. So keeping that in mind, let's go through each one. The first one says y equals 5x squared. This x term is squared, so this is not a direct variation. This is a quadratic. Y equals 3 divided by x. This is not a direct variation. The x term is never, ever divided, never divides a number. It never divides a number. We have y equals 4x plus 5. Because of the b term, this is not a direct variation. We have 4 equals x times y. I don't see that with either one of these equations, so that's not a direct variation. And then we have y equals 10 times x. This is a number times the k. That works. And then I have 15 equals y divided by x. It looks very much like this one, so that works. That's a direct variation. And then I have a line that does not go through 0, 0. This is not a direct variation. However, this is a line that does, so this is a direct variation. Then I have y equals x divided by a number. This works because this is the same as saying y equals 1/2 times x. This works. Y equals 1/5 times x works. Y equals -1 divided by x. We cannot divide a number by x for it to be a direct variation. Y equals a decimal times x. That works. And we have this curve. All direct variations are straight lines, so it does not work. Lastly, direct variations, word problems. So things that we know, y equals k times x, and varies directly means equals k. So y equals k times x, okay? They want you to find k. The first thing you're going to do is to find k. And then you're going to write that equation. So finding k, we know that y equals k times x. We know our coordinates are x equals 2 and y equals 17. So we have 17 equals k times 2. Divide 2 on both sides, and we found k. K equals 17 over 2. Now I can write my equation, which is y equals 17 over 2 times x. The next one, we're going to find k, and then we're going to write the equation, and then we're going to find a when b equals 6. Okay? So moving back, let's look at our direct variation. It's not in terms of x and y. We have a varies directly means equals k times our variable b. So a equals k times b. That means a is 20, so 20 equals k times b, which is 5, right? Solving for k, divide 5 on both sides, and k equals 4. Now I want to find my b. So given my equation is a equals 5b, or 5 times b. So a equals 5 times b. It says find a when b equals 6. So 5 times 6 equals 30. And here's my answers here. I have k, I have equation, and I have a equals 30. Okay? Moving on. 24. It is the equation 10y equals 4x direct variation. If so, what is the constant of variation? So 10y equals 4x. How do I prove that this is the direct variation? Well, it's going to be in the form y equals some number times x. So that means I need to get y by itself and see if it's true. I get y equals 4 over 10 times x. If I simplify, y equals 2 over 5x. This is my equation. K equals 2 over 5. The constant of variation is 2 over 5. Next, it says, is the equation 3x minus 5y equals 15 a direct variation? If so, what is the constant of variation? Remember, direct variations have no b's. So let's see. Let's get the y by itself. I'm going to subtract 3x's on both sides. I get negative 5y's equals 15 minus 3x's. Divide both sides by negative 5. And y equals negative 3 plus 3 over 5 times x. And because of this number term by itself, this is not a direct variation. And I didn't answer the last question fully. The last question asks whether this equation is a direct variation. Yes, it is. So I'm going to say direct variation. Okay, moving on to this. Now, with this, when they give you a table of values, what they're asking you is to find k for each one. So here, for each pair. So are the k's the same? That's what they're asking. Are the constants of variation the same? So remember, k equals y over x. So I'm dividing the y by the x. So negative 8 divided by negative 2 equals 4. For the next pair, 4 and 1, so 4 divided by 1 equals 4. K equals 12 divided by 3, and it's 4. So my k's are all the same, so y equals 4x is my equation for these pairs of numbers, and this is a direct variation. 27. If y varies directly with x, write and graph the equation that relates x and y when y equals 5 and x equals 20. Find k. So k equals y divided by x, or 5 divided by 20. My equation is 1 over 4 reduced. My equation is y equals 1/4 times x. And that means for my slope, I'm going to go up 1 and right 4. All direct variations start at 0, 0. So y-intercept is 0. So I go up 1, right 4, and I create my line. Here's my equation. You can check it in your graphing calculator. Moving on. That is the end of your Unit 5 review. You guys have done a good job so far. Very, 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 very proud. Have a good day. Your test is going to be next class. Have a blast.